Hello everyone, this is Mr. Appel, and today I'm going to show you how to do question 4A on the word problems practice sheet from section 2.7. So here we go. So here we go. Okay, so I'm going to read through this question, try to figure out the important information. Question says, I'm doing a cylinder. I've got my formula for a cylinder up here, volume and surface area. It says I want my container to hold exactly 5 liters of liquid. So that's a volume. So I want my volume to be 5 liters. This conversion tells me 5 liters is 5,000 cubic centimeters. So I'm going to go ahead and convert that. So I know that I want 5,000 cubic centimeters to be the volume. So I plug that in for the volume. It also says I want to use exactly 2,000 square centimeters of material. Well, the material for this container means the outside. That's the surface area, so that's this. So that means I'm going to have a surface area is going to be 2,000, and that's going to be 2 pi r squared plus 2 pi r h, because that's the formula for surface area. Okay, and now I need to read what the question's asking for. It says, what could the radius and height of this container be in order to meet these requirements? So I need to write a function that says when this is going to be true. The problem is I have 2 different equations. I have 2 different variables. So I need to essentially solve this system of equations. In other words, I need to write one variable in terms of the other. And since the radius appears twice in this equation over here, it's going to be easier to eliminate the height because it appears just once. So going back to my first equation for the volume, I'm going to go ahead and solve that for h. So I'm going to divide both sides by pi r squared, and I'm going to get h is 5,000 over pi r squared. And then I'm just going to take that and plug it right in for h in the other equation, in the surface area equation. Okay, so I get 2,000 equals 2 pi r squared plus 2 pi r h, but of course that h is now being substituted for with 5,000 over pi r squared. And now I have one equation that I can try to solve for r. I can try to find out what values of r, what values of the radius, would make this equation true. And that's something I'm going to do with the calculator. Before I do that, I want to simplify this a little bit just to make it easier, honestly, to type in the calculator. You could type it in just like this, but that's kind of a mess. So I'm going to do a little simplifying. I see that pi and that pi can cancel, that r, and one of those r's can cancel. And so I'm just going to rewrite this equation. So it says 2,000 is 2 pi r squared plus, that's 10,000 over r. Okay, now I'm going to go ahead and plug that into my calculator. So what I want to do is see when does this whole thing equal 2,000. So I could set it equal to 0 and find the zeros of this equation, but I think an easier way to do it would be to write y equals 2,000 as one of my equations, and then y equals 2 pi. I'm going to use x instead of r because that's the variable your calculator likes, so 2 pi r squared plus 10,000 over x. And now I want to see when those two things are equal. Now before I graph that, I need to think about my window, what the possible values could be. So if I go to my window, I'm thinking my x is my radius, so I don't need to look at negative values. So I'm going to start that at 0. Not really sure, just looking at this, what kind of a radius I might get. So maybe I'll go out to something like 50. I really don't know at this point. I'm just guessing. In my volume, which this is a function, the surface area, I know here I can do a little predicting. I know I want to see when this thing on the right equals 2,000. So I know my y value needs to go up to 2,000. So I need to go a little higher than that. And these are all things you should think about and not just totally randomly guess. So maybe I'll go up to 2,500 so I can see over the 2,000 line, and maybe I'll go up by, I don't know, 500 at a time. That's not so important. So let's see what happens when we graph. And I see this little piece. Now this is actually a piece of a rational function, and I know that because I see this r in the denominator, but I don't really care what else is going on. Again, I just want to know what r values will make this thing equal 2,000. I see that that happens in two places. So I'm going to calculate those two possible values. So second calc intersect. I'm going to select the first curve, press enter, second curve, press enter. Don't really have to think about that too much because there's only two curves. I'm going to arrow over. I'll take the first one, the one to the left first. So I'm going to put my guess, put my cursor close to that. Press enter, and there's my intersection. I see when x is about 5.532. It's about 5.532. I see that that works. So I'm going to go ahead and put in when x, or in this case r, is about 5.532. That was a possibility. But I also have to calculate that other intersection. So second calc intersect. Oops. Yeah, I'm going to select the first curve, the second curve, and this time I'm going to arrow over close to the other intersection to calculate that one. And I see when x is about 14.420. 14.420. So the other option is 14.4, whoops, 14.420. So those are my two possible values for the radius. If you're wondering why there's two possible values, why in the real world there are, if you imagine this cylinder could be a really kind of, if you have a big radius, it could be really wide and not very tall. It could be something like that. Would be one possibility. But you could also have a very small radius and be much taller. You could have something like that. So they both make sense. So you could still get that same volume and that same surface area with very differently shaped cylinders. So that's if you're wondering why it makes sense to have two different answers. And finally, the question asked for radius and height. So now I need to use this. So if the radius is 5.532, I'm going to take that 5.532, plug it in right here, because this tells me that the height is always 5,000 over pi r squared. So I'm going to plug in 5.532, and I should get a height that is approximately 52.006. I should pay attention to my units. These are all centimeters. And if I have my radius of 14.420, I'm going to plug that back into that same equation, 5,000 over pi r squared, and that should give me a height of 7.654 centimeters. And depending how many decimal places you rounded to, you might be slightly off of that, but that is how you solve a problem like number 4a. That's all for now. I hope this was helpful. Thanks.